this is Britt Castle with another example video from the SavvasRealize Algebra 2 textbook. This one is lesson 1.1, example number 4. So this is an example continuing on the interval lesson. Okay, so where it's talking about what values of x is the function increasing, this is just asking for an interval. So we're going to show it using interval notation. So when they say increasing, they're talking about a positive slope, which is really what we've been doing this whole time. That positive is hideous. Let's try that again, shall we? So what they're really asking for is where is the graph going up when you travel from left to right? Which by now in Algebra 2 you should be aware of what positive slope means. So on my graph of the example, we're looking right here at this kind of upward bound on the absolute value graph. And then it does a second part to the question where it's asking for what values is it decreasing. That's of course going to be looking for a negative slope. Now this example is fairly similar to the last one in that there's a section of this that is not defined as positive nor negative. We identify that as the part where the slope changes direction. So right here at the very vertex of the v, there's actually no slope here at 0 because it's changing from positive to negative. So when I go to describe my intervals, for example for the positive slope one, I'm going to look, and as I'm traveling here on the line, this arrow here is telling me that the graph's going to continue to go on for forever. So if I were to shade my x-axis for all the parts contained in the blue, it's going to go all the way that way, all the way to negative infinity. If I do the same thing with my negative slope, this graph has a negative interval, or I'm sorry, a decreasing interval on the x-axis all the way here to positive infinity. So for my increasing interval, I'm going to say, well, I know I go from negative infinity here on the left to 0 on the right. And I say you can't ever reach negative infinity, so I'm going to use a curved bracket. And because it's not defined as positive nor negative at 0, you're also going to use a curved bracket at 0. For my decreasing interval, I know that I'm starting at that 0, and it's not inclusive of the 0, just like it wasn't up here. And then my graph goes all the way to positive infinity. So notice I'm always going from left to right as I'm creating this interval. That's really important as you move into calculus, because if you put it in the other direction, you'll get negative answers for some of your work. Alright, so now we're looking at, again, the increasing and the decreasing. So example A here, or part A here, has a parabola. So the parabola, as I look from left to right, is going uphill on this red interval. That's my increasing interval. So if I were to shade my x-axis for everything that's on this red section, it would be right there. For my decreasing interval, I'm going to use this kind of teal color. For my decreasing interval, as I go from left to right, I'm kind of falling down all the way over here. So if I were to shade my x-axis, the part that takes over the blue, is everything here heading that way towards infinity. So my values I'm going to use for my boundary, I know I'm going to have negative infinity and positive infinity. You will almost always have those in your intervals. And then the kind of cutoff point for these is right here at 2. Okay, so remember, 2 is here where it's starting to change from a decreasing interval to an increasing interval. So at 2, this is an undefined thing. That means we're going to be using our curved brackets for both of our intervals. So I'm going to go ahead and just put my curved brackets right away. And then you just kind of go from left to right, right? So the left boundary on all this pink stuff is 2, and the right boundary on all the pink stuff is infinity. So my increasing interval goes from 2 to infinity. My decreasing interval starts over here at negative infinity, and then the blue goes all the way here to 2. So my decreasing interval goes from negative infinity to 2. Now this last one kind of throws kids off a little bit because it's a straight line. There's no change in direction here. Put some arrows on here. So if I'm looking for an increasing interval, I'm looking for where this graph has a positive slope, and there isn't one. So with interval notation, there's not really a way to show no interval. So I just say none. And then in terms of decreasing, well, this entire thing is decreasing. So the entire x-axis would be taken over by this idea, all the way to positive infinity, and all the way back this way to negative infinity. So my decreasing interval would be from negative infinity to positive infinity. If you weren't using interval notation, you would say x is decreasing for all real numbers. Okay, so the way that you show all real numbers to show everything on the x-axis is to use that little double R thing for real numbers. That's another way as well. Although most of the time you'll just show it with that interval notation. And that is it. And that is example number 4, y'all. Until next time.